at it. Now we're going to do the hard part. You're not going to like this too much, I don't think, because truth value can be difficult, but I think you're going to really get this. So just hang with me. Let's talk it out, and then we'll do a couple of examples. Now, for a biconditional statement to be true, both the conditional statement and its converse also have to be true. Now, if you have a conditional statement or the converse that's false, then the whole thing is false, okay? So it's actually a little more cut and dry than some of the other things that we've done. So example 3, we're going to analyze the truth value of a biconditional statement. We're going to determine if it's true, if the biconditional is true, and if it's false, we need to give a counterexample. So again, we're practicing that skill. Can't just say, well, no, that's not true. Well, why not? Give me an example. Give the counterexample, and that's how we're going to get around that. Okay, so let's take a look. Here's our biconditional statement. A square has a side length of 5 if and only if it has an area of 25. So we need to split it out. We need to use these skills that we've already learned. So we need to write the conditional statement. If a square has a side length of 5, then it has an area of 25. Okay, so we need to check the truth in this. All right, so let's say we have a square. What we know about squares is that all sides are equal, and when we find the area of a square, we take a side, we multiply it to itself. 5 times 5 is 25. So yeah, the statement is true. Now let's look at the converse. Okay, if a square has an area of 25, then the side length is 5. Okay, so again, we're still talking about a square. They gave us the area of 25, and if we work backwards, will the side length always be 5? Yeah, it will. So we would say that definitely this biconditional is true. So I'm going to put my answer out here to the side since I have no more room here. Okay, so yeah, that original biconditional in letter A is definitely true. Now let's look at letter B. All right, conditional statement. The number n is a positive integer if and only if 2n is a natural number. Okay, so the number, okay, if n is a positive integer, we all know what that is, then 2 times n is a natural number. Okay, so let's take a look at that. If it's a positive, I'll circle it so it makes sure it doesn't look like a T. If n is at integer, if n is a positive integer, then 2n is a natural number. Well, natural numbers are numbers that start with the number 1 and go forward, and they're not fractions or decimals. So if we have a positive integer, any positive integer I put in there for n is not going to be a fraction or decimal. I'm going to end up with a natural number. So yeah, I would say that this is definitely true right here. Okay. Now let's look at the converse. Okay. If 2n is a natural number, then n is a positive integer. Okay, so we reversed it now, and we have just a little bit of a problem, because if I set, let's say I said, they said, well, 2n can be any natural number. Well, let's pick a couple of natural numbers. Let's do 2, all right, because we got to figure out what n is. So that gives me, yeah, 1's a natural number, positive integer. Let's do 2n equal to another natural number. Let's set it equal to 3. Uh-oh. Now we have n is equal to 1.5. That's not a positive integer. It's positive, but it's not an integer. So the converse is false, because 2n can't be any natural number. It would have to be any even natural number in order for that to be true, and it's not. So this whole thing, that whole biconditional, is false. Okay, all because the converse ended up being false, because I found a counterexample when I tested that theory to figure out what n could be. All right, so I'm going to give you a bonus point for each one. So a +1 for 3a and a +1 for 3b. I don't know why they keep misspelling if. Maybe that means if and only if. That could be it. It may not be a misspelling. That's the funniest part, is you just never know in your book if that's, you know, a typo, or if it really has a deeper meaning to it. So anyway, try that on your own. If you can find a counterexample, then definitely write that down so I can see that. All right, bring your questions to class.